Hey guys, welcome back. So in the last video, we saw some of the examples of data structure and algorithm from our day-to-day life, whereby we saw that directly or indirectly, we always use data structure in our everyday life. Now in this video, let's see what are the types of data structures that we have. So on a very high level, data structure can be divided into two categories, that is primitive data structures and non-primitive data structures. Now what do we mean when we say primitive data structures? Now primitive data structures are those data structures which are given by a given programming language. So let's say if we are working in Java, these are the data structures which are already defined by Java language. Similarly, if we go for C, we get int, float, character and so on for other programming languages as well. Now when it comes to non-primitive data structures, it can be divided into two categories, that is physical data structure and logical data structure. Now what is physical data structure? Array and linked list are typically called physical data structure because they are implemented standalone and they are physically present in the RAM. However, when it comes to logical data structures like stack, queue, tree, graph or even hashing, these data structures are logical in nature and they are dependent on the physical data structure for their implementation. So let's say if we talk about stack. So stack has its own concept of push and pop, but when it comes to implementation, it can either be implemented in array or using a linked list. There is no third option. Similarly, queue, if we want to implement, we can implement either using array or linked list. No third option. So we can clearly see that these data structures over here are logical. That is, they have their own concept or their own way of computing the data. But when it comes to implementation, they have to come to physical data structure. Now you might be wondering that why do we have so many different types of data structures? So the answer is simple. All these data structures have their own properties, which is very unique in most of the cases. So depending on the problem that we encounter, we have to make a best choice of which data structure we want as on that point of time. Like in the previous example, we saw that when it comes to parent-child relation, tree works perfectly. Then computing a distance from one city to another, graph works perfectly. If you want to implement a queue, then queue data structure works. Fine. So I hope you have understood what are the types of data structures that we have. So with that, we come to an end of introduction chapter. In the next chapter, we'll start going little more technical and we'll understand what is recursion and how do we use it. So let's do that in the next video. Thanks for your time. See you in the next video.